This video is for Math 60, and I think this is the last topic we're going to cover for the course. And this is about area and perimeter. So I've talked a little bit about area. Area is a measurement of square units. So for instance, let's say we've got, let me draw a little bit better rectangle here. Okay, so let's say we have a rectangle here that is, let's call it 6 inches long by 3 inches tall. Each one of these little pieces represents a square inch. It's a square that's 1 inch on each side. Okay, and so the number of square inches that fit into this rectangle is going to be 18. That's the whole idea of area, okay, is that everything is measured in terms of these square units. Now the perimeter for this rectangle is a linear measurement, okay? Now if you think about the difference between one dimension versus 2 dimensions, right? A line is one-dimensional, a square is 2-dimensional, right? The line only has well, you can go backwards or forwards, whereas in the square you can go backwards and forwards and up and down, so there's 2 dimensions. Okay, so the perimeter is measured in 1 dimension, and that perimeter is going to be the distance around the outside of the figure. So you've got 2 sides of 6, 2 sides of 3, 12 and 6 is going to be 18 inches. Okay, so notice that the perimeter units are just linear units, okay? And whereas the area here, is that right? The perimeter and the area end up being the same thing? 6, 12, 50, they do, okay? So that's not necessarily the greatest example, but the thing that I wanted to point out is the difference in units, right? The area is measured in square inches, which are these little squares, whereas the perimeter is measured in linear units. Okay, well, let's look at another quick example here where the answers won't turn out to be the same. Let's see here. Let's say we've got something 10 feet in that direction and maybe, let's say, 15 feet in this direction. Okay, so our area here would be length times width, 150 square feet, or you can call it square feet like that. Either way is fine. Perimeter in linear feet is going to be 15, 30, 40, 50. 50 feet. Okay. All right. So there's the ideas of area and perimeter. Now this assignment is based on something you'll see on the final exam where you're given the measurements for a rectangle, and they ask you to give the measurements for a different rectangle that has the same perimeter but either a greater or smaller area. Okay? So I'm going to go over a bunch of examples before that, but before we get to it, let me just tell you something about area in a rectangle, okay, with the same perimeter. The biggest area is going to come from a square. So let's say, let's say we've got a square that's 10 units on either side. The area is equal to 100, let's make them centimeters, and then this will be 100 square centimeters. Now, if we want to keep the perimeter the same, right, but change the area, let's say we take 5 off of these 2 sides, so now they're just 5 units, 5 centimeters long, and we add the 5 onto that width or length there. I guess that's the width. So these are now 15 and 15, and these are 5 and 5. Now notice the perimeter here is still 40, But our area in this one is 75 square centimeters, smaller than the 100. Okay? All right. And so if we wanted to get a larger area, we would take some length off of the longer pieces and add them to the smaller pieces. That would make it more of a square. Okay? And if you want to make the area smaller, then you want to take pieces away. So for instance, we could take more off of these 5s and add them onto the 15s, and then I think the area would get even smaller. Let's see what happens if we do that. Let's say we take 3 more centimeters off of this. So now the thing is only 2 centimeters wide. And if we added those 3 on here, those would be 18 centimeters long. Okay. Now notice our perimeter is the same. It's still 40. Okay. P equals 40. But now, 40 centimeters, now our area is only 36 square centimeters, whereas here it was 50 and here it was 100. Okay. So that's sort of an overview of what we're going to be talking about in these problems. And I'll draw some more pictures as we look at the examples. Okay, so problem 2, let's see here. We've got a rectangular lot, 70 meters wide, 110 meters long. Okay. Give the length and width of another rectangular lot that has the same perimeter but a larger area. Okay, so what is the perimeter here? Let's see, this is 180, so that means the perimeter will be double that, 360 meters. So we want to keep the perimeter the same, but we want a larger area. So remember, the largest area always comes from a square. And we talk about this, this is actually a classic problem in a calculus class. Where we kind of look at optimizing things, okay? Find the biggest possible figure given certain constraints or the smallest possible cost. So if we make this more square-like, that'll increase the area, right? And number 2, we want a larger area. So let's take 10 off of that length and add it onto our widths. So now, well, not quite. Let's make it like this. There we go. So now these will be 80. And these will be 100. Okay, still the same perimeter, still 360. What's our area now, though, is 80 times 100, or 8,000 square meters, whereas over here, let's see, I think that's going to be 7,700. If we do 70 times 110, yeah, our area here was 7,700 square meters. Okay, so you can see the more square-like we make this, then the bigger the area gets. And if we take another 10 meters off of these lengths and add them onto the widths, then we have a square, right, that's 90 on all sides. Our perimeter is still 360 meters, but now our area is 8,100 square meters. So the answer to this question, you may be sitting there thinking, well, what's the answer? Okay. Well, there are going to be multiple answers. Okay? 80 by 100 is a good answer. 90 by 90 is also a good answer. Okay? The key is that you want to keep that perimeter the same, but you want to increase the area, and the more you make it like a square, the bigger that area will get. Okay. Now, in some of these, they ask us to make the area smaller, and so in that case, what you want to do is you want to make that long side even longer. Let's see. Yeah, so problem 4 is like that, so let's take a look at it. So problem 4, we've got a rectangular field, 85 by 55. And these are also meters. So 85 meters, 55 meters. Okay, what is this? Let's see here. This is 170. This is 110. So our perimeter there should be 280 meters. Okay, now to make, and let's find the area as well. Let's see, 85 times 55, 4,675 square meters. Okay, now the problem in number 4 is asking us to make a smaller area. If we wanted a bigger area, we would make this more square-like, right? We take away from the bigger sides, add it to the smaller sides. If we want a smaller area, we're going to make this longer side even longer. So let's take 5 off of these, add it onto here. Now we'll have 90 meters this way, 50 meters this way. So this is 180, this is 100, still got the same perimeter, but now our area is 4,500 square meters. And so, again, what's the answer? In this case, our answer is 90 by 50. Okay? And you could do 100 by 40 and so on. Okay? The longer this side gets, the smaller your area is going to get. And that's what we're looking for in problem 4. All right. Well, let's look at a couple more of these. Okay. Let's do problem 8. What do we have? 130 by 85. So 130 meters, 85 meters. Okay, so let's see here. What's our perimeter? It's going to be 260 and 170. What do we got there? 430. So our perimeter is 430 meters. And our area, 130 times 85, 11,050 square meters. Okay, so problem 8, we want the same perimeter, but a larger area. Okay, if we want a larger area, that means we want to make this more square-like, so let's take away from the longer side, add it to the smaller side. Let's see here. What do we want to do? Let's just take 10 away. So now this will be 120 meters on the lengths and 95 meters on the widths. Okay, so now our perimeter, let's see here, is 120 plus 95 times 2, still 430, but what's our area? 120 times 95, area is 11,400 square meters. That's bigger than what we started with, and so our answer here is 120 by 95. Okay. Well, let's look at problem 10. Problem 10, 85 by 115. Okay. Oh, there's 115 yards. 115 yards and by 85 yards. Okay. Okay, so this is 230. That's 170. That should give us a perimeter of 400. Yep. So our perimeter here is 400 yards. And what's our area? 115 times 85, 9,775 square yards. Okay, and And what do we want? Oh, this is problem 10. So we want a smaller area. Okay. Well, let's see here. We make a smaller area. So let's see. If I take 15 off of here and add it onto here, this will be 100 and this will be 100. And that'll actually be a square. See, now I'm going in the wrong direction here. I got started off in the wrong way. Okay, so if I take away from the larger side and add it to the smaller side, that'll give me an area of 10,000 square yards. That's bigger. That's not what we wanted. So what we want to do is take away from the small side and make that long side even longer. Oh, let's just take 5 yards. Let's make this 120. And then this one will be 80. There we go. And this one is 80. Okay, so there's 240 and 160. We still got a perimeter of 400. And then 80 times 120. 9,600 square yards. So it's smaller. And that's what we asked in problem 10. So that's the key. Notice how I got thrown off. Initially in this problem I made the area bigger for a minute. So it's always important to go back, reread the problem, make sure you answer the problem as it's asked. And in this case, we would answer it 120 by 80. Okay, so I think the next video I make will be a sample final exam, and so that'll be some review to get us ready for the final. I'll send out more information about finals week next week, and then hopefully we'll make some appointments for everybody to come in and take their final exam. So, as always, if you have any questions, please let me know. Thank you.